and then plus by P. Okay. So that is your By, and because By is equal to Cy, so you also By is equal to Cy. Okay. So this is the reaction at By and Cy. Okay, so it's a function. It's not a function. It's omega over 2 L minus 2A plus P. Okay. So now we're going to form the shear force and bending moment equation now. Okay, so what I'm going to do is we're going to do the shear force and bending moment equation. Okay, and then we're also going to concurrently draw our shear force and bending moment diagram. So you're going to see how they are drawn. Okay, so let's look at shear force. Okay, shear force and bending moment equation. Okay, so we're going to start our analysis at point A. Okay, we're going to look at point A, and for this case, at point A, x is equal to 0. Okay, so if you look at our diagram over here, this is our datum, right? Point A is where, so if you have a variable x as a slider, right? So at point A, x is equal to 0. Okay, so we're going to draw a very thin slip of the structure at point A. Okay, so this is our structure at point A, very thin. So it's as x equal to 0. Okay, so it's just a line. Okay, so this is your point A. So at point A, we know that we have a force coming down, which is P. Okay, and then this is on the left hand side. Okay, this is on the left hand side, LHS. Okay, so on this thin line on the right hand side, later on you'll see this better. On the right hand side, right, you're going to have a shear force V as a function of x going down, and then moment is going anti-clockwise, m as a function of x. I will elaborate this further when we do the next section. Okay, so we're going to stick with this convention first, right? And then our variable over here, so this is our datum, this is our slider, x. Okay, so we are going to carry out static analysis. So static analysis is positive, that's going up. Summation about forces in the y direction is equal to 0. So you have minus p, right? Minus v as a function of x is equal to 0. So v as a function of x, now this is equal to minus p, right? So v as a function of x, when x is equal to 0, is equal to minus p. So we know at point A, v x is equal to 0, this is equal to minus p. Or you can call this the shear force at point A is equal to what? Minus p. Okay? So from here, we can do we're going to take moment. So summation about moment in the z-axis. Okay, along the about the z-axis, the moment is about z-axis at a distance x. So for this case, a distance x is equal to 0. Okay, so as I say, bear with me later on when you do the next position, it's clearer now. Okay, so what we have over here, so we have p multiplied by 0 because x is equal to 0, yes or no? So p multiplied by 0, anti-clockwise rotation, so plus by m as a function of x is equal to 0. So m as a function of x is equal to 0. Okay, or you can call this m where x distance is 0, this is equal to m. At point A, the moment is equal to 0. Okay. So this is our shear force and bending moment constants at point A. Okay, it's not equation because we have what? Absolute value. Okay, these are absolute value. So at a fixed point, what we see is an absolute value. Next, we're going to do when x is sliding between point A to point B. Okay. So now you can see this clearer what is going on now, okay, because I need some meat, okay. Right, so now we're going to look at from point A to point B, right? So the operating boundary now is 0, x, and going to what? A, okay. So now, you look at, so we're going to sketch this now. So this is point A. Now, we have not reached point B yet. I repeat, we have not reached point B yet, okay? So the data is left, okay? So this will be our slider, X, right? And then we have a load coming down here. And this load over here is P. So on the right-hand side, we have over here V as a function of X, M as a function of X. Now, the thing now is this. Y, right? If you look at this structure over here, right? If you look at this structure where I'm drawing now, what comes to your mind? Anyone? What comes to your mind? What's the problem with the direction of Vx? Anyone? If this thing has been left in free space, what will happen? The entire structure will drop down, yes or no? Right? Most of the time we will think, hey, Eugene, isn't Vx should be going up? Right? No, it should be going down, is correct. But why is it? Okay, why is it? Okay.
Because it's not a reaction and it's a vertical shearing force.
No. Okay. So why this is happening? Okay. So watch this. Okay. So our geometric datum is always fixed. Okay. But our analysis direction is from left to right. Okay. So this is left to right. Okay. Analysis direction. Okay. So when we do this, okay, we are going to make an assumption based on positive shear and positive bending moment. Okay, we're going to have analysis. So we're going to do both ways, okay? I'll show you what do I mean by both ways. So I'm going to draw a center line. On the left-hand side, our analysis will be left to right. Analysis. So what do I mean by that? As you can see now, if this is my geometry, or this is my structure, right? This is my structure. And the geometric datum did not change. Geometric datum will never move. It's still from here. Okay. So this is our slider X. And this is our analysis direction. Okay. Analysis direction. When we do this, right, the shear force at X, okay, at a distance X, is always coming down, and the moment will be going for anti-clockwise. So this is known as positive shear, positive moment notation. Nothing to do with what we're trying to deal with reaction. No, it's just an analysis, okay, for the notation so that we can sketch our shear force and bending moment diagram based on this notation. That's it. It's like in our numbers, we start from 0, right? Positive is going towards the right hand side, negative is going towards the left hand side. Same case for this, okay? And when we do your analysis on a beam, right, datum did not change, okay? 0 point is still 0 point, okay? And then if we analyze from left to right, based on positive shear, positive bending moment notation, the shear force will be coming down, the bending moment will be going anti-clockwise. Now, what will happen if we do our analysis from right to left? Okay, what will happen if we do our analysis from right to left? So remember, the datum still did not change, right? Now our slider is in going this way. So this is still our x, right? So this is the other end of our structure. Okay, so this is at the other end of our structure now. Okay, so if you ask me where's the entire structure, so the dotted line is our entire structure, including the solid line, right? But now, okay, so let's and I'll give you a dimension from here to here is L. Okay, so the distance from here to here, this entire distance is L minus what? X. Okay, so now the geometric datum still is at the same position. X is still going towards the what? Right hand side. But now our analysis direction changes. So now this is our analysis direction. So when you swap over your analysis direction from right to left, our shear force will now be going upwards, and our bending moment will now be in a clockwise direction. Okay, and this is solely for us to sketch our shear force and bending moment diagram based on our notation. Okay, if not, there's no reason for it. Okay, so this is the mathematical inclined assumption that we are trying to sketch our shear force and bending moment diagram, and we have to assume positive shear and positive bending moment. Okay, so this is critical. If I will ask you what's going to be critical in this topic tonight, so this is really important. You have to know this. Okay, or not, your direction is all wrong. Okay, and then when your direction is wrong, nothing is right. Okay, right. So from here, that's why now you can see here from here. Why is this thing? Okay, so from here, that's why our shear force and bending moment are in that direction. We are doing our analysis from where? From left to right. Later on, we'll do right to left. Okay, because I don't want you all to be a one pony egg. I want you all to become a what? A two pony egg. That you can go on either way, and there are advantages for this. Okay, there are advantages why we need to know two ways. Okay. So again, protocol is the same. You do summation of forces in the y direction is equal to 0. So this part is still easy. Okay. Point load is equal to P. Now is minus P minus V as a function of X is equal to 0. So V as a function of X is equal to what? Minus P. Okay. Then, so this is an equation now. This is as a function of what? A function of X now. Okay. The one that we have done before, right, over here is at a specific point. So it's going to be a constant. There'll be no function of X. It's going to be a constant. Okay. Then from here, we do summation about moment in the Z direction at point X. So where are we taking our moment? So I'm going to draw a dot now. Okay, so you'll see where the dot is. We are taking the moment where the slider or the variable X stop. Okay, so that is where we take our moment. Okay, so from here, so the P will be going in an anti-clockwise direction. So P multiplied by x, okay, then plus by m as a function of x, the whole thing will equal to 0. So m as a function of